Okay, here in this video, we're going to look at what we're going to call a complete change of variables. In the other integrals that we were looking at using our u substitution, we were basically able to look at the problem and kind of find a pattern and pick u and then identify du. But sometimes that's not going to work with every integration problem. It works with a lot of them. But for example, here, if we try to use just kind of our u substitution we did before, we would say, well, we have x plus 1 times the square root of 2 minus x. And if we see the 2 minus x, we're thinking that's the inside part, so we're going to let u equal 2 minus x. And then we would take the derivative, and the derivative of u would simply be negative 1, or simply just negative 1 or negative 1 dx. And if you notice, we have this x plus 1. We have the dx and we can multiply by a negative, but the problem is we have this x plus 1. So here we can't just get this to fit the pattern that we need to have our u and du in the problem. So this is going to require us to use this complete change of variables. So what we're going to do now is we have u, which is the 2 minus x. We know what du is, but we need to find a value for x. Well, if u equals 2 minus x, then if we solve this equation here for x, we would get x, move x to the other side, so we get x equals, and move u over, we get x equals 2 minus u. And the other thing we need to do is we need to solve for dx. Well, du is equal to a negative dx, so we could solve this. That means we would move the dx over, so that means dx then would be equal to move the du to the other side, and that would equal a negative du. So what we've done here is we've actually solved for every piece. We have our u, 2 minus x. We took the derivative to find du, which is negative 1 dx. And then we solved the first equation for x to get 2 minus u, and then we solved for dx, which would be a negative du. So if we perform the substitution, in place of the x, we would plug in 2 minus u, and then we have the square root of 2 minus x, which would simply be u, and then dx is equal to a negative du. So there's the complete substitution. In other words, we've eliminated all of the variables x and changed them into u and du. So there's no longer x dx, it's strictly u and du. So now we just have to simplify here, and I notice here that I substituted the x and got 2 minus u, and this should be plus 1. I left out the plus 1 here. So if we simplify this, then we would have the integral of 2 plus 1 is 3 minus u multiplied by the square root of u, and I'm going to go ahead and maybe write this as u to the 1/2 power to make it easier to work with. And the negative sign here, I'm going to take our negative du. The negative, I'm going to pull out front, so then we're just left with du. And now I'm going to distribute the u to the 1/2, so we can just simply distribute that. And we don't want to forget to bring down our negative on the outside, so we would have then 3u to the 1/2 minus u to the 1 plus 1/2 would be 3/2. And now we can simply integrate each piece individually. Now we still have this negative out front, so we'll leave that there. And we would get 3u, well, if we add 1, that's going to be 3/2. And once again, instead of dividing by 3/2, I'm going to multiply by the reciprocal, which would be 2/3 minus u raised to the 5/2, and multiply by the reciprocal would be 2/5. And we have our plus c. So there's our integral. Once we were able to do the complete u substitution here for u and du, it turned out to be very simple. Well, before we resubstitute back in terms of x, I want to do a little bit of simplification here. And to do that, I'm going to distribute the negative. We can distribute the negative here. I'm going to go ahead and multiply our terms out. So we have 2/3 and 3, so the 3's cancel. So we would end up with a negative 2u to the 3/2. And the negative and negative would make this a positive 2/5 u to the 5/2. And we still have our constant. So now we can do our substitution and recall that above u was equal to 2 minus x. Okay, that was what we had up here. U was equal to 2 minus x. So now we're going to resubstitute back in terms of our variable x. And maybe before we do that, you may see this every now and then. Notice we have a negative out front. We could switch the order here so that we have the positive 2/5 out front. So we'd have 2/5 u to the 5/2 minus 2u to the 3/2 plus c. So that may look a little bit nicer. It's not necessary, but a lot of times as mathematicians, they like to have this first term to be positive. So now, if we do our resubstitution here with u equals 2 minus x, we would have 2/5 times 2 minus x raised to the 5/2 minus 2 times 2 minus x raised to the 3/2 plus c. And there's your answer. This is our integral. Now be aware we could go a little bit further here. You could do some factoring. We have this 2 minus x to the 5/2 and a 2 minus x to the 3/2. So you could certainly do some factoring here, but for our purposes, I'm going to leave it here. What I want you to see with this example is that sometimes the way we looked at all those previous examples with u substitution, it's not always going to work. You may have to do what we call here a complete change of variables in order to integrate.